Hi! In this lesson, we are going to introduce a Python calculation that will help us identify a number's factors even easier. As a reminder, our task is to sort the 56 jawbreakers into bags evenly. We determine the jawbreakers' factors by looking to see if the number of bags divided them evenly, and by that I mean there were no jawbreakers left over. The green arrows show there were no remainders, indicating factors and viable bag options. The red arrows show where there are decimals in the calculation, indicating leftovers or remainders. This is great, but it's still a lot of manual calculations that we have to do to determine all the factors. So here's the question. What if we want the computer to determine if a combination is a possible bagging option automatically, without needing a human to look for a remainder? Can we have the computer check to see if the calculation jawbreaker count divided by bag count has a remainder or not? Remember, this calculation is jawbreaker count divided by bag count. So can the computer complete this calculation, then determine if there is no remainder, bag count is a factor of jawbreaker count, or if there is a remainder, bag count is not a factor of jawbreaker count? The answer is yes, and it can do so with something called the modulus. The modulus is a mathematical calculation that produces the remainder of a division problem. The symbol is the percentage sign. Let's look at a few examples. 5 divided by 3 is 1 with a remainder of 2. So if I wrote this as a modulus calculation, 5 mod 3 is equal to 2, the remainder of the division problem. And 11 divided by 4 is 2 with a remainder of 3. And so the modulus calculation, 11 mod 4, is 3, the remainder. And 8 divided by 2 is 4 with a remainder of 0. So the modulus calculation, 8 mod 2, is equal to 0. Reminder, if the remainder of a division calculation is 0, then the numbers divide evenly and one number is a factor of the other. Taking these three examples, 8 mod 3 is 2, so the remainder is not 0, and therefore 3 is not a factor of 5. And 11 mod 4 is 3, so the remainder is not 0, and therefore 4 is not a factor of 11. And 8 mod 2 is equal to 0, so the remainder is 0, and therefore 2 is a factor of 8. In general, we can say if A mod B is equal to 0, then B is a factor of A. Okay, great. This will be super helpful with our calculations. Let's see this in action. So let's type out the calculations that we were just looking at. So we'll start with 5 mod 3, and we'll run this. We expect to see the result of 2, which makes sense. 3 goes into 5 once with a remainder of 2. And the next one we have 11 mod 4, which again 4 goes into 11 twice with a remainder of 3. So that makes sense. And this last one we have 8 mod 2. And as we know, this will have a remainder of 0. So everything works as expected here. And we can also do this with variables, which again is going to be our best practice. So let's create two variables, number 1 and number 2. And we'll set their values and then print the calculation number 1 mod number 2 and run this. And we get a result of 3, which again makes sense. 6 goes into 9 one time with a remainder of 3. And let's change this to 5 and run it again, and we get a result of 4, the remainder of 9 divided by 5.